inspection by IGNO authority. Okay. So all of you write your enrollment number and your name on the chat box.
ତୁ ରଖେ ମୁଁ ପଛରେ କଥା ହଉଛି କ୍ଲାସ ଷ୍ଟାର୍ଟ ହେଲାଣି।
Okay, my microphone was mute. Now, what I'm saying that only one participant name I find in my chat box, that is Chinmay Tripathi. Okay, so you have to write your enrollment number and your name on the chat box first. So once you write your name and because see why I'm saying, because what I can see the name, it may not be your actual name, because Chinmay Tripathi has written, but in that Google Meet I can find his name written as Raj something. Okay, so that's the reason that whenever you joining, write your enrollment number and your name on the chat box. Okay.
Hello, sir. Good evening.
Yes, good evening.
Yes, good evening.
Yes, you joined late. I'm
Yes, you
repeating the
joined
same
late.
instruction.
I'm repeating the same instruction. Okay, sir.
Okay, first of all, you mute
Okay,
your
first of all,
microphone.
you mute your microphone. Okay.
Okay. So when you want to speak, you just uh, unmute and speak. Okay. And during the class, if you don't have any bandwidth problem and all, so better you can on your video so that it will be interactive session. You write your name and enrollment number on the chat box. Okay. So that I can confirm the number of participants in my class. So till now, we have only 3 participants here. So I'll wait for another 1 or 2 minutes, then I'll start, because it is already 7 past 8. So is it Sainigam joined right now?
Sir, my name is Devasis Sanavote.
No. Okay. Anyway,
Sir, this is my YouTube channel, so the name is Sainigam Vaktative.
that is the reason I'm
That is the
asking
reason
you
I'm
that
asking
write
you that
your
write your
name and enrollment
name
number in
and
the chat
enrollment
box,
number in the chat box
Okay, sir.
because your
because
login names are
the login
different.
names are different.
Sir.
Because if I'll not get that correct participant logged in my class, so I may have it to force you to remove it. Okay, so that is not the wise way to do the things. Because unless until you can write your enrollment number, I cannot start my class. Yes, nursing has raised hand. Yes, nursing. Uh, I got your enrollment number and name. Nursing, want to say something? You have raised your hand in. Devasis Senapati. Okay, fine. Another login I find, the name shows me Madhusmita. Yes, it is same login. Okay, let's start for today's session. I'll share my screen. So this is your third semester, and I assume that you have some basic idea about what is called software, what is called program and all, because the topic what we have, or that subject we are going to discuss, is that software engineering, that is MCS-34. Now I'm sharing my screen, then we'll continue with that topic and those related things. Okay. Just 1 minute. Okay, I'm just sharing my screen. You will get it now. And you just confirm me that whether you're able to see my shared screen or not. Okay. Okay. I have shared it. Can you see this screen? That's PowerPoint presentation. I have
Yes, sir.
shared it. Okay. Now, can you see this one? This I have made it full screen. Okay. Now, let's start with that today's topic. That is, you may have got your materials. If it is not, you have that materials are available. Okay, you can go through that. So we have unit 1, 2, and 3. Three units are there in this MCS-34. So I have to start with the first unit, that first book you may have received. So that unit 1 is titled as software engineering and its models, and the code for this course subject is MCS-34. So today we have to start with that basic concept of what is software engineering and how it is useful uh, to develop a software. So let's start with that first introduction. So introduction to software engineering. Now here you can find two terms are there before I'll go to the introduction. Okay, one is called software, another is engineering. Uh, Now, you know what is software? Yes? If I ask you to, anyone you can opt that, what is software, how you can define that one? How you can define software? Okay, if it will be interactive, it's more meaningful. Anyway, yes, say something.
Software is a program which is used to run hardware.
Okay, it is a program which is used to run a hardware. Okay, we can define like that also. And another way you can define that normally when you say the software, it is a set of programs. Okay, and we know that as you say that program is used to run a hardware or actually to control a hardware, or we can use the to give the instruction to that hardware to how to perform certain task. Okay. So when I talk about that software, it is a set of programs. Okay, it is clear. And what is program? We know because I assume that in the previous semester you have done some basic programming knowledge you have. Maybe you have done some programming in C or C++, right? Now, what is engineering? Okay. Now, normally you can find this term engineering is basically used to perform some kind of modeling, or basically we just do some kind of quantifying and we can measure it. If I can measure something, okay, and find some kind of dimension, some kind of structures, so we can just perform some kind of mathematical modeling on that to find out what kind of operational things we can perform on that. So that is basically engineering deals with. Now, but here in our case, so you can take up that other engineering fields, maybe mechanical or civil or this, you can find that those are associated some kind of things which are physically visible and you can touch them and feel them. But in case of the software, we cannot see them. Okay, we cannot physically touch them, but we can feel them. It is there, and we have to perform that kind of engineering methodologies on that. Okay, that is a main challenge in that. So That is the purpose of studying this software engineering, that how you can define the software, how you can quantify that, and all operational things we have to perform. So next, if I ask that what is software engineering, so we can define it like it is a engineering approach to develop a software. Now, when you talk about the engineering approach, okay, that means we can say that it's building construction analogy, means how we can define that. Now, if I say that engineering approach to build a bridge in a civil engineering, then you can say that we have to make some kind of survey of that particular river bed, okay, based on that soil conditions we have to find out. So that means you have to go for some kind of planning on that, and based on that planning you can estimate what kind of materials are required or what amount of materials is required. All these details you can find it from that kind of planning and that approach. The similar kind of planning and approach we also require when we want to develop a software. Okay. Now that is what we say, that it is a systematic collection of some past experience we have to use. Okay, by applying some kind of techniques, methodologies, and guidelines. So this is a, we try to define this software engineering in a generic term, okay, in a generalized way. So based on this, IEEE proposed a formal definition of your software engineering. Okay, so this is what we have, that IEEE is proposed formal definition of your software engineering. So it says it is an application of a systematic, disciplined, quantifiable approach to development, operation, and maintenance of software. Now, earlier we know that when we talk about a software, it is a set of programs, means we have certain programs are there. And it says that is the application of engineering to software. So that means we can go for a systematic, disciplined, quantifiable approach to the development and the operation and the maintenance of the software. And in the part B, it says that the study of approaches in A. That means altogether, this is the what we mean by that software engineering. Now, to define this one in more elaborately, you can find it says that the software engineering is an application of, that is how to apply, of systematic, discipline, and quantifiable approach. Okay, that means you have to go for a systematic order. Okay, in a disciplined approach, you have to go for that, and it will be quantifiable. Now, suppose if I say I have to develop a software, means I have to develop a kind of programs. So that can be a simple small software. Let's say I have to go for a automation of a library system. Okay. Now, what kind of operations we can perform in a library generally? So you can catalog the books. Okay. So that is the librarian point of view. As a user point of view, you can requisition for a particular book. Okay, and you can issue it. And after studying or reading it, you can return it. Okay, so that is issue and return is one kind of operations in a library. To maintain these records, that is the job of your librarian. Okay, and sometimes we also procure some books, okay, from the different publishers. So these are the different kind of operations you have in a library. Now you want to design a software for to manage these operations. Okay, so when you have to think about that, I have to design an application or that set of programs to manage this one. So you have to find out what are different operations are there. So suppose I take up one module, that book issue and book return. Okay, that is one module or one small unit of operations I can take up. Now for that, you said that you have to go for a systematic approach. So what you have to find out? Okay. So in this operation, what are the things involved? So that means you can find at least a user is involved or a library users. That can be a student, that can be a teacher. Okay, if it is a institutional library, if it is a general library, okay, so that can be that each users can be varies from the different work of fields. That's different. So purpose that you have a user who is going to issue a book, a librarian who is keep all this information in his register. This is the operation. So we have to write his book number, book name, book title, maybe a publisher's details, and the date of issue and the period of issue. That is how many days he has to take up. 2 days, 3 days, 4 days, that depends. So these are the operations you have done involved. So how you can approach? So you have to find out that user. So you have to keep the details of that user. Who is that user? Is a student? If he is a student, from which branch or which course? What is his roll number? All details. Okay. How to manage his data? That is another part. So that is what I mean by the systematic approach. Okay. Then you have to quantify. So means when I think about that, I have to develop a library system. I have to quantify that how big or how small it is, okay, for my development of that particular. So I have to quantify that approach for my development of that particular software or that product, how that will be performed, that operations, and how I can manage it. Okay, means how I can modify later on when I have to add on some new functionality to that particular software. That is what I mean by the software. Okay, so that is we apply the engineering methodologies over there. So that is the application of engineering. And what we study or the detailed study of entire this operation is here that approach to this. So that is the basic meaning of this particular definition which is given by your IEEE. Okay. Next, that how this evolved, that software. So evolution of, so we call it the evolution of an art into an engineering discipline. So designing and application is a kind of art. Okay. So that is how you can evolve through that engineering methodologies. Now you can find that in earlier days, okay, actually you can find that sometimes that we can categorize the different era of that different kind of programs we have developed. Okay, so in that earlier days, uh, can you see my screen or it is changed? Okay. Now see in this initially when we talk about that those days when we don't have any systematic development approach, so it is normally the programmers use an exploratory style. Now normally nowadays this term programmers are little bit misnomer kind of things. Nowadays most of the uh, workforce which are involved in the developing the softwares, okay, we call them the developer rather than the programmers. Okay, there is a certain reason is there. Reason is nowadays most of the application developments is done using different kind of automated tools are there. Okay, maybe I am using different kind of IDEs. Okay, so I think you know what is IDE. Okay, IDE, integrated development environment for different programming development. So we can use these IDs for different languages. Okay, now suppose you want to develop a mobile app, so you may use that Android Studio. Okay, So, or if you use some kind of other language, new language like Kotlin, like that, they have that IntelliJ, there is a ID. So that kind of different IDs. Or if you're a Java developer, then you may be familiar with NetBeans or Eclipse. So that means those environment gives you a lot of facility, whether it is minimize your coding. Okay. So you have to apply the right logic and it is done. So that is we call this nowadays the developers are there, the programmers are not there. But earlier when we don't have this kind of IDs, a programmer or that particular software developer, he has to do everything. So start from the writing that each and every code its own. Okay, in a scratch, normal in a text pad or notepad or in a text editing environment, he has to write. So that is what you have to talk about the programmers. Nowadays also we have the programmers who are actually writing those core programmings we are doing. Okay, like writing a device drivers or developing a cell for a operating system, that kind of things. But what is you can find that you say that in early programmers used an exploratory way of defining those softwares or designing those softwares. So what we call the build and fix means I write certain code, then I find there is certain problem is that a test with some test data it is not working, so I have to modify that. So again, you have to rewrite and modify this one. So that is what we call that. Sometimes we call that exploratory or build and fix way of style. Okay, so that is what we call that. It is a dirty programming that quickly we develop a program, and if it is not work properly or if it requires some modification, again you can reject it and rewrite once again. So that is what you have the build and fix approach. So that is the initial way of developing those programs. Okay. So that means we have different imperfection means that it is not going to be gives you the deliverable what you actually want. So again we have to find it and we can fix it. Okay, so that is the initial approach because that time that programs are very small and our resources are also very limited. Okay, so that is the approach initially we have when we start with the development. Okay. Now, what wrong with this type of exploratory systems? Okay, so problem is that when the size of those programs or what you call the softwares are grows in an exponential way. So that is we can that beside that exponential growth of your effort, cost, and the time. So the problem with your size. Okay. So that means this exploratory style usually result in unmaintainable code because there is no systematic approach is there. There is no modular approach is there. Okay. I'll talk about that, what kind of modularities are there in subsequent classes. Okay. So some kind of problems arises. Okay, it is not a maintainable. Okay, when the code is large. Okay, and it is very difficult to use this kind of exploratory style in team development. Means there is no certain module is there. So nowadays, normally you have a large program. Suppose you talk about that library system. So if I can try to divide that one in a different module, then you can find okay, so you can find that particular module with a specific operational things. Suppose if I say that in library systems I have to develop a module for inventory system, means how many books I have, how many books I have to procure, what are the different publishers are there for different subject books. Okay, so their details I have to keep. So that is one module I can keep. Okay, so that is nothing with to work with that book issue and return for a user of that particular library, maybe a student, maybe a teacher. Now I can have two different modules are there. So this kind of approach is not there. In traditional or this exploratory systems, if I go for this library system, only one or two persons may be there, or usually one. Okay, he has to do everything. Okay. So when you try to divide this one in a team environment, so this kind of exploratory style of development is not preferable, or actually not gives you that kind of results. Okay, these are the major drawbacks of this initial way. So that is what we have. Initially, we have that programming is very small. Okay. Now think about those or that approach is you can start with. Suppose think about that. I have a system. Okay, let's say take up this one. Suppose I have a system as initially you have talked about that we have to have a program which will be interact with my hardware. Now suppose I have a hardware, I don't have any software. Okay, I have given you a processor. Okay, I have give you a input device. I'll give you a output device. Okay, but there is no software is there. So in that case, what you have to do? So first you have to write a certain code which can take your input from your input device. Okay, and that with the you have to write some kind of set of instructions or some kind of routines that will be connect with your that controls unit with your input device. So that is I mean that you have to write a small operating system first, which will be allow you to interact with these devices to communicate to each other. Okay. Once it is done, then you can give your data to be read by this first phase program for processing. Then it will have to have another program which will allow you to send your output to the your output devices. So this kind of things are there. So initially that resources are limited. So we have to write in this way. So we have to go for this exploratory system. But when my requirements are increases, software size also increases, cost of the software also increases. So this approach is not feasible. Now, what kind of implication in this program development? We are going to develop some kind of program. Now, what kind of implications you can find? If I have a small program, okay, we may have some kind of small variables are there, and it is easily within the control of an individual. So we can say it is within the easy graphs of an individual. When the numbers are independent variable in the programmer increases, okay, it is beyond the capacity of an individual to control on those individual variables. So that means you have to have a large effort. Suppose think about that. If I ask you to write a program using a C program, to write a program to take a number as input and check whether it is a prime or not. So how many variables are required? Hardly 4, 5 maximum. Okay, but it is required. Suppose to read a number, that is one input variable you read. Okay. Then for the loops, you can take one variable over there, and some intermediate results you have to keep. There is another 2 or 3 maximum variables you require. So you can find that limited to 4, 5 variables, your job is done. Okay. Now, suppose if I say that now you have to increase the capacity of that program, that no, now you have to modify this program. So that will first, if I input any number, it will say it is prime or not. Then if I want, it will print all the prime numbers between a certain range of numbers I have to input. Suppose if I say print all the numbers, prime numbers between 1 to 100. Okay, so that will print. Or another operations I can add into that. Whenever I want that give me 10 prime numbers, it will give the 10 prime numbers. If I ask that 100 prime numbers, first 100 prime numbers, it will give the 100 prime numbers. If you say the 500 prime numbers, it will give like that. So that means I can define that number of prime numbers also. Now you can find that means for each operations I have to add one different functions. I am just considering as a C language because you have done the C programming in your previous 2 semesters at least. Yes, am I right? You have done some C programming? Yes.
Yes, sir.
Okay.
Yes, sir.
For my information, because I am going to use some kind of examples in next this during these classes. So just tell me that have you done any programming in C++? Means you have some idea on that object-oriented programming concepts? Any
Yes, sir.
object-oriented programming concept? Okay, very good. So that will help me to insight my examples into that. Okay.
Sir.
So so that is what I'm saying, that if I increase number of functions into that small program, so number of variables will be increases, and gradually you can find it is very difficult to control or manage all those things. Or if I say that uh, print the result of 5 students, you can say it is fine. Okay, I can declare five different variables with 5 roll numbers and 5 names. It will be managed. Suppose one roll number, one name. So 5 into 2, the 10 variables I can manage. But if I ask that print that 100 students data, then easily you can think about no. If I want to go for the 100 students, only the name and roll number also, I have the 200 plus variables I need, and that is very difficult to manage. So immediately you can think of the okay, if I use an array, it will be easy. Yes. So this kind of approaches means immediately you can think of that how easily I can manage my data and my operations so that I have to give a less effort. Okay. So this kind of planning, okay, you have to make it before you start your coding. Actually, in real life, when we go for that actual software development, so before you can go for the coding, so all these things you have to plan accordingly. Okay, how you can plan this one? By go for that study of that entire system. Okay, in a systematic approach. So that is what we talk about, that software engineering approaches are there. Okay, without that it is not possible to develop such a critical or those kind of complex excuse me systems. Okay, so that is what we find, that we can find that quickly we have to have a large effort to master those problems. Okay, so that is what we can deploy some kind of principle. So we can find that we principle deployed by the software engineering to overcome human cognitive limitation means our limit cognitive limitation means our capacity in terms of our memory, in terms of our brain capacity, we have some kind of limitations there. Or also we have the reaction times also. Okay, if I ask you to add 5 numbers, so it may take at least 30 to 1 minute, 30 seconds to 1 minute maybe. Okay, but same thing if I go to ask to my computer to perform, so it may take a fraction of a seconds. Okay, then or less than that. That means we can measure those times. So that is what we talk about, that human limitations are there. Now here we have to go for two basic principles in that how you can manage those. We talk about it when my system increases enormously large. Okay, I have a huge system to develop. Okay, so how you can deploy these two systems? One, applying the abstraction. Okay, second, we go for the decompositions. Okay, now here we have to understand the things. Now, keep in mind that my approach is to develop a large software. Okay, maybe it is a library system, but that library catering to a 5 different courses. Maybe suppose that is in a let it be a school, simple, a standard school having class 1 to 10. Okay, and normally in our cases you can find any schools we have in a particular class we have more than 1 or 2 sections are there. Okay, Now think about a simple school is there, class 1 to 10 is there, 10 classes, suppose I take about 10 classes. Each class has minimum in an average. Okay, in the higher classes we have more number of subjects, lower classes we have the less number of subjects. So I can take up, suppose average I have 5 to 6 books or subjects are there. Okay. Now in some cases in each subject we have more than one book. Suppose if I say that in class 8, 9, 10 or 7, 8, 9, 10 science we have minimum nowadays 4 books, which is chemistry, botany, zoology. Okay, or minimum 3 books, physics, chemistry, biology. Okay, botany, zoology, 1 book, biology. Now you can find some. Now think about that. A library in such a school, I have to manage it. So you can find the number of subjects are more, number of students are also more. If I consider, okay, we have a limitation that only 40 students in each class. Okay, so 40 into 10, we have 400 students. 400 students means 400 students information you have to keep. Minimum information. Think about his identification, that is roll number, class, okay, name, okay, and minimum contact. Okay, suppose here you can find a 4 to 5 fields are there for each student information. Then the number of book issued to him, subject wise. Okay, now for in a particular subject, we have the different publishers are there. Let's say I have 4 different publishers are having that book. 5 to 6 different authors are there. Now you can find that in a smaller unit also, if I go for this kind of approach also, you can find the size is increasing. And here I cannot apply that build and fix or those simple methods, it's not applicable. So you can find. So what way you can just manage this one? So for that, you go for some kind of abstractions. So what do you mean by the abstractions in that case? Okay, so first think about that abstractions. So we can define this abstraction, okay, as it is specified over here, that it is simplify a problem by omitting the unnecessary details. We have to focus or we have to pay the attention only one aspect of the problem and ignore irrelevant details. Okay. So we have to, I'll come to a concrete example, the languages or that ways, but before that we can go for a generalized example on that, how to understand this abstraction. Now, this is what, suppose you are asked to develop an overall understanding of some country, let's say. Now, in that case, it is not possible. So, what you can find? So, no one in his right mind would meet all the citizens of that country, visit every house, and examine every tree of that country, let's say. So, it is not possible physically. But your task is to, you have to understand some overall understanding of a country. Then what should be your approach? Okay, so you can possibly refer to the maps, right? That is what. Okay, now when you see that map, okay, what you are doing, you are ignoring the irrelevant things, means which is not required. I have to find out, suppose I can take up a demographic map. Okay, I can find out what kind of peoples are there. Suppose if I take up a, what kind of population is there, okay, what kind of ethnicity they have, what kind of culture they have, like that information I can get it from that map. Okay, so I can assume that, okay, this kind of peoples are staying in this part of country. Okay, so that is what we mean by that abstractions. Okay, we have to find out in that way. Now for example, now you have some programming idea also. Now for example, suppose you may have used that C programming, and there is a simple function called a printf. Okay, you are using the printf. You are writing printf within double quotes. Your message it is displayed. Now here also you are actually using some kind of abstraction. What kind of abstractions? You never bother about that how this function printf works. What you are bothered about? You bother about that how to print my data in output screen. If it is a number, I have to use that syntax provide me that formatting strings like %d or %u. Okay, depend on the number types. Okay, I have to use. Or if it is a string, I have to go for %s. Okay, or other character specification I have to use. So, but you never bother if it is not absolutely necessary to open that printf function, okay, where it is written in my library, and see that how they are giving the instruction to send my data to the output screen, right? Have you ever thought of like this? No, because it's not required actually. Okay, my task is to send my output to the output screen. So I have a available function is there. I have to use it. Okay, so I have to ignore that. So we are applying this kind of abstraction whenever it is required and wherever it is applicable. So that is one way we have to go for. Now, if you think about no, I have to print my name, so I have to write my own function. Okay, that you can do it. Okay, but it will take time. Okay, I have to write my own function that will interact my hardware, that display type. Okay, based on that, I have to go for that some assembly coding or that low level coding which is available. I can do that. Okay, you can do that, but it will take time. Okay, you unnecessarily waste your time. So that is what we analyze this one over here in this. It is say that if a person think about that, okay, no, I have to meet each and every person of that people of that country, and he can take up that initiative, but he'll never complete his task which is assigned to him because it is take a lot of time. Okay, but if that approach is that if you go for a map, then he can solve his problem. So that is what should be the approach. So whenever we think about a large system to be developed, we go for some kind of abstractions are there. That is what we mean. So you can find this approach is there. So if we go for an object-oriented concept also, there also you can find some kind of abstractions we are developing. Okay, and sometimes we have to correlate the things also like that way. Okay, we can again we in your data structure also you have to apply this kind of some kind of abstract data types. Okay, you have used. Okay, so stack as a abstract data types you have used this one. Okay, in your data structure concept ADT. So this is the basic or preliminary things about your software designing approaches. So that is what we talk about that or to try to make you understand that abstraction. Okay, so that a map in fact is an abstract representation of a country. Okay, that is what we have to approach. So here also in the software also we try to go for some kind of functionalities. How that operational things will be implemented, sometimes we ignore them. It is not required for to know for everyone to do that one. Okay. Now next part is the decomposition. So as this words means the decompose means you have to break it out. Okay. So we have to decompose a problem into many small independent parts. Now, as I take up that initially that example of that library management system, okay, where you can start with that kind of decomposition, like as I said, I try to divide those different operational areas in small modules. Like one module, I can say that issue and okay, or issue and return is one module. Okay, procurement, that is your inventory management. So that is one module. That is, I'll procure some books from the different publishers and I can maintain an inventory. So using that catalog, a user or the student can issue a book. Okay, there are two different things are there. Then we have to manage one those number of users for that library, that students or type of users. So that is one module is there. So that is we have to decompose that complete complex library systems into a small different modules. Same things you can find in every approach. If I go for a HR management system, okay, for a certain organizations, we have to define the different modules. There may be I have a performance appraisal module one there to find out the different employees' performance. So that will be managed. Then we have that what we call that payroll, okay, because that HR has to give the details that whether an employee is present his entire month of work or not. So that details whether he will be given the incentives or not. So that is also a one module, the payroll, which is also input from your HR system, okay, like that, because they have given the attendance and all. So that kind of small modules are there. So that is what you have to think about it. You have to decompose into that problem into the small independent parts. Then we have to integrate them later. Okay. So that is what you said, that the small parts are then taken up in one by one and solved separately. Okay. Or sometimes we call it that we use a term called the divide and rule. Okay. If I have a large problem, divide it into smaller ones, and as it is a smaller one, the size is small, I can manage it easily. So that is the way we can use the decompositions. So that is idea is that each small part would be easy to grasp, okay, and easily solved. And when we have the full problem to solve, okay, that part are solved. That means if I goes on solving the each small part, so finally you can find that entire part is solved. So that means finally my all modules are tested and performed properly, then I can integrate them. Okay. So these are the way you can use. So there are different way of demonstrate the decomposition principles. Okay, so different way. So this is the generalized examples you can find over here. We have take up as an example that if I say that try to break a bunch of stick tied together, okay, so you're not able to break it, but you just untie it and then try to break individual sticks. You can successful on them. So that is the way. So that is the approach. So similar principles we use in terms of decomposition. Okay. So you can understand that a particular book, okay, when the contents are organized into the independent chapters. Suppose if I say, now suppose if you take up a software engineering book or this whatever the topics we have started with, okay, everything is in one unit. Suppose you can find that in your software engineering book also you can, as I told that there is a three different units are there, unit 1, 2, 3. So why they have made it like that? So it is easy to understand this individual units. Okay, and if I make it a single unit and with this no points in there, and if I not have even have a single paragraph also, then you can find a lengthy document is there. Okay, you can hardly find any interest to read that one. Okay. So that is the reason that we try to segregate some subject into different chapters. Okay, and then we can manage it well. That is one example of your decomposition principles we are using. Okay. So after that, you just compare each one. So here also you can find that initially when I say that the definition of your software engineering, there you can find that we can have that we can develop, we can maintain. So all these are different. So you have to quantify the things, then you have to develop, and then you have to manage it, or we can make that operational, then we have to maintain it. So we have the separate parts, okay, to understand this one. Okay. So this is what we have about this. Now, before I go to this next term, that software crisis, okay, if you have any specific queries, you can just ask. Okay. Uh, Someone is joining right now. Okay, I just admitting them. Okay. uh, can you see that screen what I have shared, or it is not visible now? Okay, before I go to the next, this software crisis part, okay. If you have any queries, whatever you have discussed till now, we can have some kind of interaction, okay, because actually it is already we have only 4 minutes there, so that is what I don't want to start this new unit over here.
Unit over here.
Okay,
Excuse me, sir.
so yes,
Yes.
Sir, can I got this notes that help me to study better?
yes, I'll share this my
Yes, I'll
PPTs
share this my PPTs
after
Okay, sir.
completion of each
after
unit.
completion of each unit.
Okay,
Okay, sir. Thank you,
okay.
sir.
Once I'll complete one unit, I'll share this
I'll
PPTs.
share
Don't
this
worry. Okay,
PPT.
that you will get.
Don't worry.
Okay,
That you
sir.
will get.
Okay.
Thank you, sir.
And my suggestion is that you just go through your book. That is okay. In just 1 minute, just I'm just sharing your book. You can find over here in my screen. Can you able to see this book now? This is your unit 1. You just confirm me, because I have shared your unit 1 book. Is it visible?
Sir.
Yes, sir.
Okay. So I hope this book with you, that
Yes, sir.
maybe a hard copy, maybe soft copy.
Yes, sir.
Soft copy
Maybe
also
a hard
available.
copy,
If you
maybe
don't have,
soft
then
copy. Yes, sir.
okay. Okay. Now my suggestion is just go through this book and its chapters. Okay. So that wherever you have any specific doubt on this concept which is mentioned over here, okay, we can take up this one and we can discuss on that. Okay, so this is some introduction parts are there. Okay, so you have to go through this and you just raise your questions whatever is there. Okay. Okay, any other questions if you have, you can ask, or tomorrow we have another session at the same time, that is the same, that 7 to 8 in this evening. Okay, so it will be better if you try to join before 5 to 10 minutes, so that we can exactly start at the 7 and we can finish it up. Okay, so if you have any other queries, you can raise, or we can close the today's session, and I can continue that software crisis part the next class onwards. Yes. Okay. Then shall I call it as a, or I just end this meeting for today? Okay, one thing, just 1 minute. Let me. I have five participants. That is, I have one. You just check. You have given your name and enrollment roll number, because this is, will be taken as your attendance. So I can find Chinmay, Narsing, Devashish, Madhusmita. Okay, only 4 of you have given your name and enrollment roll number in the chat. Okay, so another one is missing. So if you not give your name and roll number in this chat box, it will be not taken as your attend this session. So it is required by that IGNO officials for your attendance. Okay. I think Sankar Naik, you have not given your enrollment number because other fours are given. Okay, fine. I got that, Sankar Naik. Okay. Thank you, all of you. So I'm ending today's meeting.
Meeting.
Thank you, sir.
Thank you, sir. Namaskar.
Thank you, sir.